This should look familiar from middle school. So like I was saying, vertical angles are created when you have two lines that intersect with each other. So if I have one line, I'm going to draw another line. It's going to kind of make like an X. It's not necessarily a 90-degree angle. Don't stress about which direction or like necessarily how wide the angles are. Just draw a crisscross. And now what we're going to do is we're going to put numbers in these angles. So I'm just going to call this angle 1. I'm going to call this 2. I'm going to call this 3 and 4. So when you have vertical angles mean that they are opposite of the intersection from each other. So the vertical angles in this picture would be angle 1 and angle 3. We could say angle 1 is congruent to angle 3 because they are vertical angles. Vertical angles are opposite of the intersection from each other. We also have another pair of vertical angles, which would be angle 2 and angle 4. So I'm going to use like 2 slashes for these ones. 1, 2. Because they are not all congruent to each other, I'm going to say that this has 2 arcs. This has 2 arcs. Angle 2 is congruent to angle 4. If I had more intersections, I could then add angles with like 3 arcs. So this is stating that 1 is congruent to 3. 2 is also congruent to 4. 2 and 4 are both obtuse. 1 and 3 are both acute. They're both small. So remember, this is the congruency symbol. That means that they are equal measurements. Is that your music? Okay. Adjacent angles, these share a common ray or a common side. So adjacent angles, I'm going to draw an angle, like an acute angle. I'll just draw it like this. Boop, 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 boop. And then I'm going to put a ray in the middle of it. It's not an angle bisector like we talked about yesterday. It's just somewhere in the middle. It's splitting that angle. An adjacent angle shares a common side. So if angle 1, I'll put a little 1 here, and I'll put an angle 2. They're not congruent to each other. They're just have a common side. So we can say that they are adjacent because they are directly next to each other. So 2 angles that share a side. The next type of angles that we're going to talk about is a linear pair. A linear pair are angles that are next to each other, so they are adjacent, but they form a straight line. So linear, how much does a line make? 180. So a line is 180 degrees. So basically 2 angles that add to make 180. So I'm going to draw a straight line, and then I'm going to add an angle to it. This is technically 2 angles in one picture. I'll call this angle 1 and angle 2. They're not congruent, but what I could say is angle 1 plus angle 2 is equal to 180 because they are a linear pair. Pair means 2. Line adds to make 180. They are also adjacent, so that's why the vocabulary kind of ties together. This is an adjacent angle. 1 and 2 are still adjacent, but now they form a linear pair because they add to make total to make 180. Complementary. Does anybody recognize this word from middle school? Complementary, some of you? Okay, complementary, this adds to make 90 degrees. So complementary is 2 angles that are adjacent, and they add to make 90 degrees. So if I have a right angle, because a right angle is 90 degrees, and I'll call this angle 1 and angle 2, I could say angle 1 plus angle 2 is equal to 90 degrees. They are also adjacent. They are directly next to each other, but specifically they're complementary because they make 90. The way you can remember this is because they might just use the word complementary. They might say 2 angles are complementary. You need to remember that it's 90. You can do that by if you draw a line with your C, it creates 90 in the word. Your C becomes the 9, and then the 0 is like the 0, or like the O is like the 0. So that's one kind of like trick way to remember the vocabulary. The other word that they could use is supplementary. Supplementary add to make 180 degrees. So the S, if you connect your S, it makes an 8. So they add to make 180 degrees. So these two, it's basically the same thing as like a linear pair. If I draw a picture, I'll draw opposite two angles that are next to each other. These add to make 180. I could say angle 1 plus angle 2 equals 180. The reason why they use the word supplementary is technically different from a linear pair because there could be a third angle and all three of them could be supplementary. A linear pair is technically two angles. Supplementary could be more than one, or they could be separate. Like if I have an angle like this, I could say this is like 100. That's not 100, but whatever. And then I have another angle that's like 80. They don't have to be necessarily in the same picture together. They could be two individual pictures. They still add to make 180. What's up? Because they could be separate angles like this, like literally separate pictures, and they could say these angles are supplementary, or they could have a third angle. If I draw another ray coming out and I put a little 3, I could say 1 plus 2 plus 3 is 180. But that's why the words go in common with each other, because they basically mean the same thing. A linear pair is specifically two angles. Supplementary just means they add to make 180. Whether it's 2 angles, 3 angles, 27 angles, added together, it makes 180. These are also adjacent angles because they share that common ray. So they kind of overlap into each other. So let's get into some examples. So for question 1, we have to pick what relationship they have. What's up? Yeah. Yes. They have to be, it has to be one big angle with one inside ray to make them adjacent because they have to be sharing that inner angle, that inner ray.
So in example,
So 1 and 2 are not adjacent because they're not directly next to each other. Oh, like this one? Like 1 and 2. Yeah, so 1 and 2 are adjacent. They're also technically supplementary because they form a straight line. They are adjacent, they're supplementary, they're a linear pair. 2 and 4 are vertical angles. They are not supplementary, they are not a linear pair, they are not adjacent because they're not sharing a ray. But 3 and 4 are all of those things as well, like adjacent, supplementary, linear pair. Okay, so it's like different ways to like look at the picture. Okay, so for question 1, if I'm specifically looking at question 1 and question, or like line intersection 1 and intersection 2, 1 and 2, those angles, what type of angles are they? Vertical. So we're going to circle vertical, or like X off vertical, whatever. Since number 3 is right here, let's talk about number 3. Number 3, I have 1 and 2. It still looks like a crisscross. It looks like vertical angles, but 1 and 2 are not vertical angles. What are they technically? They are adjacent. What else are they? They are supplementary and they are a linear pair. They're all 3 of those because they're directly next to each other. They're forming a straight line, so that adds to make 180. There's only 2 angles, so they are supplementary. They are a linear pair because there's 2 of them that add to make 180. They're also adjacent because they share this ray right here. So let's go to 2 and 4. So 2, what kind of angles are 1 and 2 in problem number 2? They're complementary and what? They're not a linear pair because you're thinking the entire line, but I'm just talking about angle 1 and angle 2. I'm not thinking about the 90. They are adjacent because they're directly next to each other. They share that common ray. What else are they? Is that? Oh, that's it. I'm like lying. Sorry. So they're complementary and they are adjacent. They share a side. What about question number 4? Adjacent. Do I know they form a 90-degree angle? No, because there is no square, so they are not complementary. It's actually an obtuse angle. They are not vertical. They're not opposite of an intersection. They're not adding to make 90. They're not adding to make 180. They're not a linear pair because they're not adding to make 180. So that's the only thing they are, is adjacent angles because they share this ray. Okay, let's go to the last 2. So question number 5, we're talking about specifically 1 and 2. There is more things going on in this picture. If I have angle 1 here and angle 2 here, what type of angles are they? They are vertical. They are not adjacent because they don't have a common side. They don't have a common ray. Anything else? No? Let's go to the last one. Woo! What about these ones? They're vertical. What else are they? There's one more thing. They are supplementary. How do you know that? Nice. Since this is a right angle, that means that the other side would also have to be a right angle, which also means that this would have to be a right angle. So they are vertical, they're congruent, and they technically add to make 180. So that's the difference between a linear pair. A linear pair are adjacent and they add to make a total of 180. This is supplementary. They add to make 180. They are not a linear pair because they're not one line making 180. They're opposite angles that add to make 180. Okay, so let's go to the back and do some math. So on the back side, we have a couple different problems. We're going to name the type of relationships that they are. Technically, there's more than one for some of these. And then we're going to set up equations to solve for x. We're not going to plug it back in to find, well, do we have to plug it in? Then find the missing angle measures in each figure. Okay, so we're just going to solve for x. We can plug it in tomorrow or something, some other time. So we're just going to worry about finding x. So for example 1, what type of angles are these? Yeah, what is that? Vertical. So these are vertical. So if I think about what vertical angles are opposite of each other. We also know that they are congruent. So I'm going to put a little arc and a little arc. I know that they are the same measure. So let's use our big brains. What is an equation I could set up to solve for x if I know that they are congruent? They're equal to each other. I can't say they're equal to a certain amount. I can say they're equal to each other. So I can do 17x plus 21 equals 123 because I know they're equal to each other. This is a 2-step problem. So what do I have to move? 21. I'm going to subtract 21 to both sides. So 17x equals 102. Divide by 17. So what do I get? 6. Okay, so let's go to the second one. Yeah, just find x. We'll find x for today. We could plug it back in, but I think you guys are okay with plugging it back in. We know how to do that. Okay, example 2. What type of angles are these? They are adjacent. What else are they? They are a linear pair. What else are they? They're supplementary. So I'm just going to put sub. So either way, linear pair and supplementary, they're forming one line. You have a straight line right here. How much does a straight line add to make? 180. So I know the entire angle makes 180. So what am I going to do? So this is where yesterday comes into play, not segment addition postulate, angle addition postulate. I'm taking piece plus piece and I'm equaling it to 180 because that makes a straight line. So I'm going to do 101 minus 5x plus 2x plus 70 equals 180. I'm going to combine like terms. So if I combine my x's, what am I going to bring down? -3. If I combine my constants, which is 101 and 70, what am I bringing down? Plus 171. What am I doing to both sides? Subtracting 171. And then last subdivide. What's up? Yeah, takes a pass. Go ahead. So X can be negative. In the end, if you were to substitute this back in, it should never end up being a negative angle measure. You can't have a negative angle measure, but you can have a negative variable. Because if I were to plug this back in, I'm doing 2 times -3, which is -6. I'm adding 70, which is still going to be a positive length or a positive angle measure. Okay. How are we feeling? Not too bad. Let's do something a little bit harder. Okay, use your brains. They're adjacent. What else are they? And complementary. I know that they're complementary because if this side is 90, that means the other side has to also be 90 because it's a straight line. So the whole thing needs to add to make 180. So you could technically do one of two things. You could say 90 plus 27 plus 8x minus 1 equals 180. Or you can make your life a little bit easy and just look at this piece of the picture and do 27 plus this equals 90. So would you like to add it to make 180 or would you like to add it to make 90? Okay, yeah, let's save ourselves some work. So I'm going to do 27 plus 8x minus 1 equals 90 because I know that side has to be a total of 90. Geometry, the more we get into this kind of stuff, there's multiple ways you can do this and solve it and get the same answer. So you might not be thinking one thing, like it might be thinking something else, but it all works. So if I combine like terms, 27 minus 1, what am I bringing down? Not 28. 26. I'm going to minus 26 to both sides. Because the opposite of addition, subtraction. What's 90 take away 26? And then divide. So x equals 8. So look at example 4. See if you can figure out like what you would have to do. You have to move some pieces around. Does anybody see something that I should probably move to help me set up a problem? There's like 3 different ways you can do this and get it correct. 4. There's technically 4 different ways you can do this that I can think of. There's probably more. No, we have no idea what's happening. Okay, so there's different ways you can look at this. I suggest trying to make a full line. So is there anywhere that you can move something to make a full line to have a supplementary problem? It's a vertical angle.
Yeah.
So you can move 55 here, you can move 107 here, you can move 4 minus 2x here. They're all the same as long as they're across from the intersection. I don't have to move everything though. If I just move the 107, now I have a full straight line. And I can just think, oh, this whole thing together should make 180 because now I have a full line. I could have moved the 4 minus 2x over here and I would have had a full line this way. If I move the 55 up here, I would have had a full line this way. Either way, it's a supplementary problem, depending on which way you look at it. So I'm going to take 55. I'm going to add 107. I'm going to add 4 minus 2x, and I'm going to set it equal to 180 because this is technically a supplementary. Supplementary problem. It's not necessarily a linear pair because you have 3 angles that add to make 180 instead of just 2. So that's why it's specifically supplementary. So now I'm gonna combine my terms. I have 55, I have 107, I have positive 4. If I combine all of those numbers, what am I bringing down? 166. I still have minus 2x in the back. And now I'm going to move the 166 over. The 166 is positive, so I'm going to subtract 166 to both sides. I'll bring down my negative 2x. 180 minus 166 is 14. And then I divide by negative 2. So x equals negative 7. And once again, you can get a negative x, but when I plug it back in, I should never have a negative answer. This is 4 minus 2 multiplied by negative 7. So this is really negative 2 times negative 7. So this is really 4 plus 14. So you end up getting a positive angle measure no matter what. Okay, so you have 4 problems at the bottom of this. If you don't want to write like exactly what type of angle it is, I'm okay with that as long as you can do your math, because if you can do the problem, then that tells me you know what kind of angles there are. Okay. You got 4 problems. We were going to do IXL today, but Clever broke. So some people Clever is working for, some people Clever is not working. Like some people it's working for, some people it's not working for. They sent out an email from the district saying Canvas is, or like Focus is like down, not Focus, but like Clever is down. And some people it's working for, some people it's not. And like, so I was just like, we'll move it to Friday. So we'll do IXL on Friday. And that way, hopefully it's all fixed by then. Okay. What's up? What is that? Oh, I would have graded that.